Here we're doing 5.4. We'll deal with the last four trig functions outside of sine and cosine, but make sure you have a 5.4 classwork in front of you. These slides will go along with that. But you don't have to do a chat, but think about why the unit circle is so helpful for you. And if you want to jot down a couple things and pause the video, that's fine. Also think about why it could be more confusing or not helpful too. So if you did pause the video, some things that it's helpful for, well, we need to find side ratios. It's nice to work with a radius of 1 or a hypotenuse of 1, and that's what the unit circle does. The terminal coordinates can tell you sines and cosines because the radius is 1. You don't have to worry about y over r. It's really just y. And then it's also maybe visually helpful to kind of envision a unit circle. But that's kind of what might not be helpful, if you think about things that are not a radius of 1. Um, the sines and cosines will still remain true, which I think can be confusing because it's sine or cosine of an angle. It's just the unit circle is a device for kind of figuring out what those trig ratios are, the sines and cosines of an angle. And then obviously when you have coordinate points, like, an angle terminates at a certain coordinate point, like 2 comma negative 3, the radius isn't going to be 1, so it wouldn't be a unit circle problem. So you might be over relying on the unit circle at times, but you can still get an answer without the unit circle. So what we're going to do today is learn about the other four trig ratios for right triangles that we have, which we've done sine and cosine. So we're going to do a video within the video. That's not too much to handle, which is just a Khan Academy video. So we'll watch that.
Determine the 6 trigonometric ratios for angle A in the right triangle below. So this right over here is angle A. It's at vertex A. And to help me remember the definitions of the trig ratios, and these are human constructed definitions that have ended up being very, very useful for analyzing a whole series of things in the world. But to help me remember them, I use the word SOHCAHTOA. So let me write that down. SOHCAHTOA. Sometimes you can think of it as one word, but it's really the 3 parts that define at least 3 of the trig functions for you, and then we can get the other 3 by looking at the first 3. So tells us that sine of an angle, in this case it's sine of A, so sine of A is equal to the opposite, that's the O, over the hypotenuse. Opposite over the hypotenuse. Well, in this context, what is the opposite side to angle A? Well, we go across the triangle. It opens up onto side BC. It has length 12, so that is the opposite side. So this is going to be equal to 12. And what's the hypotenuse? Well, the hypotenuse is the longest side of the triangle. It's opposite the 90-degree angle. And so we go opposite the 90-degree angle. Longest side is side AB. It has length 13. So this right over here is the hypotenuse. So the sine of A is 12/13. Now let's go to K. K defines cosine for us. It tells us that cosine of an angle, in this case cosine of A, is equal to the adjacent side to the angle, over the hypotenuse. So what's the adjacent side to angle A? Well, if we look at angle A, there's 2 sides that are next to it. One of them is the hypotenuse. The other one has length 5. The adjacent one is side CA. So it's 5. And what is the hypotenuse? Well, we've already figured that out. The hypotenuse right over here, it's opposite the 90-degree angle. It's the longest side of the right triangle. It has length 13. So the cosine of A is 5/13. So let me label this. This right over here is the adjacent side. And this is all specific to angle A. The hypotenuse would be the same regardless of what angle you pick. But the opposite and the adjacent is dependent on the angle that we choose in the right triangle. Now let's go to TOA. TOA defines tangent for us. It tells us that the tangent of an angle is equal to the opposite side over the adjacent side. So given this definition, What is the tangent of A? Well, the opposite side we already figured out has length 12, and the adjacent side we already figured out has length 5. So the tangent of A, which is opposite over adjacent, is 12/5. Now we'll go to the other three trig ratios, which you can think of as the reciprocals of these right over here, but I'll define it. So first you have cosecant, and cosecant, it's always a little bit unintuitive why cosecant is the reciprocal of sine of A, even though it starts with a co, like cosine. But cosecant is the reciprocal of the sine of A. So sine of A is opposite over hypotenuse. Cosecant of A is hypotenuse over opposite. And so what's the hypotenuse over the opposite? Well, the hypotenuse is 13, and the opposite side is 12. And notice 13/12 is the reciprocal of 12/13. Now, secant of A, it's the reciprocal, so instead of being adjacent over hypotenuse, which we got from the ka part of SOHCAHTOA, it's hypotenuse over adjacent. So what is the secant of A? Well, the hypotenuse we've figured out multiple times already is 13. And what is the adjacent side? It's 5. So it's 13/5, which is once again the reciprocal of the cosine of A, 5/13. Finally, let's get the cotangent. And the cotangent is the reciprocal of tangent of A. Instead of being opposite over adjacent, it is adjacent over opposite. So what is the cotangent of A? Well, we figured out the adjacent side multiple times for angle A. It's length 5. And the opposite side to angle A is 12. So it's 5/12, which is once again the reciprocal of the tangent of A, which is 12/5.
So that video is good. Keep in mind the only thing that you would never have to deal with is angle A. If you think about it as a unit circle or any circle stemming from standard position, it would probably be angle B that you would be worried about, because this would basically be a quadrant 3 angle where you're going left and down and making your right triangle that way. So kind of be the angle that would start here and go to that part. So angle B is probably the one that would stem from the origin. It would be the only one that would stem from the origin. In which case the 12 would be a negative 12 and the 5 would be a negative 5 in trig. But these, I kind of just wanted the video to give you tangent and then cosecant, secant, and cotangent. And then just kind of showing you why things are reciprocals. Like, so if you had cosecant is hypotenuse over opposite, or it's also, you can think of it as 1 divided by sine, it's reciprocal. And since sine is opposite over hypotenuse, or if you want to think of it as almost y over r, you know, 1 divided by y over r is going to be r over y. Same thing with secant, 1 divided by adjacent over hypotenuse, same thing as x over r. 1 divided by that, it's just going to be r over x. And then with tangent, 1 over y over x. So tangent is opposite over adjacent. Y divided by x. 1 over that is just going to be x over y. And that's kind of how I want you to think of it in trig. Instead of hypotenuses and opposites and adjacents, think of it in terms of, you know, x's and y's, and r's for hypotenuse. So you don't have to do this in partner practice. You can do these 4 on your own since I'm not here. You'll do something in groups in a little bit. But just for these 4 questions, you can pause the video, just kind of figure out which quadrant, you know, this triangle would be drawn from, assuming that one of these angles would be the center. Actually, it all looks like, well, they're all going to be in the same quadrant because they're all going right and up. But just rewrite these as a ratio using x, y, and r instead of opposites, hypotenuse, and adjacents, and then evaluate your answer. So you can pause the video, do these 4 really quick, and then resume. All right, so if you did that, now keep in mind these are all going to be quadrant 1 angles because they all go right and up. So angle Z would be the angle you're looking at, C, C, and X for all of these. So that's part A for all of them. Rewrite using X, Y, and R. So tangent of Z, right? So tan of Z, I'll just write over here, equals, tangent is opposite over opposite over adjacent, so 21. But actually, hold on, rewriting is x and y's, and it's going to be y over x, right? The y coordinates go up, the x coordinates go left and right. So y over x is 21 over 28, which you can divide them both by 7, and you get 3/4. So tangent of z is 3/4. With cotangent, right, cotangent of x, or theta in this case, well, theta is x, is going to be adjacent over opposite, but it's just going to be x over y, right? And not in terms of these x's and y's, just in terms of x because you're moving right, y because you're moving up. So x and y is going to be 30 over 40. It's also going to be 3/4, just coincidental. Number 3, cosecant of angle C, right? So we went right now. Cosecant is the reciprocal, well, no, sorry, this is cosine, I'm sorry. Cosecant is CSC. Probably should have given you one of those, but that's okay. So cosine is just x over r, right? We've done that one before. Right, so r is obviously not 1. This wouldn't be a unit circle problem. But you could still find the cosecant of this angle. So let me see. So we have x over r, which is going to be 16 over 34, which is the same thing as 8/17. And then the last one, we have secant of c. So secant is the reciprocal of cosine. So if you think about cosine, that's x over r. So secant of c is going to be r over x, right? It's going to be the hypotenuse over the adjacent, which is x. So in this case, it's going to be 29 over 21. And that's, again, these are all finding trig ratios. That's what we're finding. These fractions represent trig ratios. All right, so basically what we can figure out is the adjacent is the x-coordinate, the opposite is the y-coordinate, and the hypotenuse would just be the radius, or r, for that case. So with these types of problems, you kind of have these, which are the last 4 trig functions. Tangent is y over x, secant is r over x, cosecant is r over y, cotangent is x over y. And that's kind of what the lesson is. And you can probably think about it and get it, but the closer you have these down to just memory so that they're automatic, probably the better. Just so you don't have to waste time. If you know, boom, tangent is y over x, you just continue the problem. You don't have to think about making triangles and things like that. So here's a typical example. Think about tangent of 45 degrees, right? So if you wanted to draw an angle, 45 degrees, you can draw a circle if you want. But 45 degrees spits you out right there. So tangent of 45, right, this is the unit circle. We know that this coordinate point is root 2 over 2. Root 2 over 2, comma, root 2 over 2. And the radius would be 1. So tangent of 45 is going to be y over x, which in this case is root 2 over 2 divided by root 2 over 2. So tangent of 45 degrees is going to be equal to 1, right? And that's kind of, another type of answer you can get one with that doesn't involve sine and cosine. Cosecant of 2 pi over 3, right? So if I think about 2 pi over 3, it's pretty close, I drew it. But right there, it's like 60 degrees, right? So my coordinates right there are going to be 1/2, comma, oops, I'm sorry, I screwed that. That's pi over 3. All right, 2 pi over 3. There we go. Coordinates right there are going to be negative 1/2 and root 3 over 2. So cosecant, right, is the same exact thing. It's the reciprocal of sine, right? So sine is y over r. So cosecant is going to be r over y, which in this case, we can utilize a unit circle because then we have a standard to go by for y, r and y. So it's going to be r, which is 1, over y, which is root 3 over 2. Instead of dividing by root 3 over 2, you can think of that as 1 times 2 over root 3. Right? 1 times anything is going to be that. You just want to rationalize this so that it's 2 root 3 over 3. Right? Multiply this by root 3 over root 3 because it's the same thing as 1 So you're not changing the equivalency of anything. So you just get 2 root 3 over 3. And then if we think about cotangent of 540 degrees, right? So, or negative 540 degrees. So if you went all the way around, that's negative 360, plus another negative 180 would spit you out right there, right? So coordinates right there is just negative 1 comma 0. So cotangent is going to be the reciprocal of tangent. So tangent is y over x. So cotangent is going to be x over y, which in this case, the x coordinate is negative 1, the y coordinate is 0. This is going to be something that we call undefined, right? So that is something that's undefined. You cannot have 0 in the denominator. So as soon as you get that, it's undefined, right? And you're going to have some other ones that end up being undefined too, because once you move one of the x's or y's to the denominator, then the possibility is that you could have 0 in the denominator, right? Because the radius would never be 0 because that's going to be 1, but x's and y's certainly could be. So with that being done, hopefully you finished the video. You can look around and find some other people that are done. Get into groups of 3 or 4 is fine. What you're going to do is the activity from 5.4. So it's on Schoolage. You didn't print anything else out besides the classwork. The homework is going to be separate, but see if you can get the activity done in class. That'd be great. And then you can start the homework if you finish. If you don't finish the activity, still just do the homework and just get as far as you can in the activity. But that's it. Thanks.